right, final one. So this will just be fresh in your head. So it's going very, very quickly. So we will need our shape booklet out and we are going to do our best to describe these. So the first thing, symmetric, skewed left, skewed right. What's the best word you could give on these? So I'm going to go through and do that for the problems, and then I'll talk about, is it unimodal, is it bimodal, is it uniform? So number one, as far as the shape goes, this is symmetric. Number two is closer to symmetrical as opposed to anything else. Number three is skewed right because the tail is on the right side. Number four, it's technically symmetrical. If I cut it in half, the left side looks like the right side. Number five is skewed left. Number six is symmetrical, cut in half and the left looks like the right. Number seven is skewed right. Number eight is skewed left because the tail is on the left side. And number eight, I would put at symmetrical or just symmetric. Now I'm going to talk about the shapes. So again, there is unimodal, which could be bell-shaped as well. And then there's no mode, so uniform. There could be bimodal. So talking about that, number one is it is unimodal, but the better word that we're going to use on this one is bell-shaped. Number two, it looks bimodal. If you wrote that, I would accept it, but that is the higher point, so I would actually just say unimodal. But again, I would take bimodal. Number three is unimodal. There's one mode. Number four, there is no mode. So you could write no mode or uniform. Number five is unimodal, or again, you don't have to write unimodal. You can write one mode. Number six, there are two high points here and here. These are the same. So two modes or bimodal. Now, the thing I cannot tell on 7 or 8 or 9 is the mode. There might be one, but I don't know what the data was that went into this, so I will not be able to tell you anything about the mode. I could compare the mean, the median, and the mode for you, but that's about it, okay? So can we describe the shape? So again, symmetric, skewed left, skewed right, without graphing it. So if the mean was 64 and the median was 70. So I'm going to do my three M's. And the first M is 64. And the second M is the median. So that's 70. So if I put my arrows in here, this is the way it would work to fit the numbers. So since it's pointing left without graphing it, I do know that that is skewed left. The ages of all the students at EHS was recorded and a histogram was made. So what I'm going to guess is that something like this, if we did graph this, most students are somewhere, you got, let's say 14-year-olds, your 15-year-olds, your 16-year-olds, and your 17-year-olds. So your freshmen, your juniors, your sophomores, your seniors, so approximately. And all the class sizes are pretty much the same. One might be a little bit taller than the other, but, well, I'm not even lining these up. But I would say it's going to be pretty similar. So as far as the shape goes, I would say that it's pretty symmetrical. One class is not crazy bigger than the other. All right. The median and then the average. So again, they're comparing the mean, the median, and the mode. So the median is 255,000. And average just means the mean, so that would be here. And if I opened it up, it eats the bigger amount. Since it's pointing to the right, this is skewed right. And a box plot that was symmetric then had a very large value added to its data set. So a box plot, that just means, if I have something like this, it's very symmetrical right now. and then all of a sudden a really large value is added to this, that's going to make a tail that goes to the right. So this would be skewed right. That big piece of data is going to skew everything. It's going to throw everything off to the right. And that's it. That is our review. So you'll be turning this in on the day of your final. And that's it.